I'm Greg Everett from Sierra Dental Tool. Sierra Dental Tool is the company behind really high quality milling tools sold through Zahn. My background is actually in the lab. I've got a lot of experience with a lot of different milling machines and CAD/CAM workflow in general. I like to tell people that I've had the chance to break a lot of things and learn the hard way. So I'm in a pretty unique position to speak about how tooling and CAD/CAM are related. So we'll just jump into it. I'm going to talk for maybe 40-ish minutes. I'm going to touch a little bit on like how to think about CAD/CAM as a broad view, and then we'll kind of dive deeper into tooling as a more of a detailed look. And then finally, I'll look at some of the common milling issues that come up in CAD/CAM and how to kind of look at them and determine what the issue may or may not be. And then we'll do a little bit of overview on what Sierra Dental Tool is doing in the industry. And we'll drive it home with a little bit of Q&A if there's anybody with questions at the end. So when we're talking about CAD/CAM, that's a broad term now. It basically means anything that's digital in nature, and most labs now have some sort of a digital aspect to their production now. And what I find is that a lot of times people tend to focus in on one point of the system, and you really should think about your CAD/CAM, your department or your process as one entity. It's an aggregate of several different pieces that all come together to make an efficient workflow. So the best comparison is kind of visualize it like a chain. One link breaks and you can have issues. So going forward, what's a good CAD/CAM workflow look like? First of all, as much as it's fun to make crowns, we want to make money at it. So it's got to work for your application. It's a lab that's making hundreds of crowns a day is going to need different stuff than a lab making 10 crowns a day. So it's important to think about all that. And then you want it to be reliable. You don't want to be spending a lot of time on the phone with support, and you want consistent and quality results coming out. So the key part of a successful CAD/CAM workflow is, first off, it's people and relationships, both internal inside the lab, employees, coworkers. Get good people who really want to put the biggest effort into the production, and then also externally. Choose your suppliers and build those relationships, because when the day comes that you do have an issue with your CAD/CAM, something breaks, a scanner breaks or whatever, which is inevitable, those relationships really come in handy. And then choose quality equipment. Ask around, ask your friends, what are they using, and make sure you're using good, reliable, consistent consumables. That's material, that's tooling, obviously, all of the above. So focusing in a little bit deeper on tooling, when we look at CAD/CAM and think about it like a chain, the tool is the end link to that chain. Like it's everything's focused on it. So all the way from your initial scanning, designing, nesting, it all culminates at that tool. And so if you do skimp on that when you're making selections, it can certainly give you bad results. It's the last thing that's in contact with your restoration before you actually get to put your touches on it. So it's potentially the strongest link in your system or the weakest link. And we like to encourage people to make it the strongest link. So, like I mentioned, often, tooling gets overlooked as part of the production chain. A burr is not a burr. So there's a lot of differences on burrs, from manufacturer to manufacturer, and we take into account all of the detailed nuances that have to do with dental, and make sure that the product we're putting out there is a high quality product. So I like to think of the tool as literally the business end of your lab. Everything's focused on it again. It directly affects the quality of your units, and thereby also affects your bottom line at the end of the day. So I'll give you a little more detail on that. So when a tool is cutting, and this is actually kind of a cool GIF of a cutting edge cleaving material. This is actually aluminum, I believe, but the idea is the same in ceramic zirconia. The geometry and the shape and the tolerances that your tools are manufactured to, they imprint themselves right onto your part. So for instance, if your tool is a little bit oversized, then you can end up with loose fits. Or if it's undersized, you can end up with tight fits. And so it's important to know that you're choosing a supplier that not only puts out an accurate tool, but also puts out a product that's consistent. And then the biggest thing we're concerned about in the lab, obviously, is cost. So this is a little breakdown on how tooling kind of works into your cost per unit. It not only does the actual tool cost come into play, but also affects your labor rates and repeatability in the form of your remake rates, which is a very important metric in the lab, as we all know. So it's important to think about the quality of the tool and ask, is it worth it to pay less for a lesser tool? And I've got a little bit of a breakdown here that we're looking at. And on the left, I've got a 20 unit yield out of a $100 puck, which amazing, you can get a $100 puck nowadays, but they're out there. And you can see at the end that the tool with a 50 unit yield is a very significant portion of the cost at around 30%. Now, when you get into our nano die, yes, it's a higher initial investment, but the drastically greater yield per tool that you get breaks down to a much less expensive milling cost. So you can see even with a $100 puck, we go from $7 to $5.70 on your cost per unit, which is really significant in terms of your business case. And then if you want to look at it just at tooling, it's even more significant. But I like to throw the material in there so you can kind of equate that to a real life situation. So back to my chain metaphor. If you use high quality tools, they're going to be your friend. They're going to be the strongest link in your digital production chain. So moving on here, as I'm sure everybody knows, we're not the only industry using a CAD/CAM system. In fact, dental is a very, very small niche in the whole scope of things. So, the vast majority of CAD/CAM process is used on industrial side. So that's automotive, aerospace, that sort of thing. Now a lot of the principles port over to dental, and so that's what I'm going to get into now. So this is kind of an interesting little GIF. It's Ken Block, rally driver, doing one of the Gymkhanas. If you want a little distraction, Google Gymkhana. It's kind of fun. So tools are very similar to tires. If you think about tires, I'm going to buy a nice, $80,000 Porsche and then put Walmart tires on it. No, you're not going to do that. They're even in the point being is that even the best tires, if you drive it like this, or if you abuse them, they're not gonna last. So there's several different things that affect tooling and how long they last in situ. And the biggest thing is the milling parameters, RPM, feed rate, chip load, and surface speed. Which RPM, that's the rate that it's spinning at. Your feed rate is the speed that the tool is moving through the material horizontally, and those two are combined to determine a chip load, which is the thickness of the piece of material that's cut per revolution. And all of these come together and they affect the entire milling dynamic. If you change one, you change the other, and certain materials, certain machines, they all have their own little sweet spots. So these things are, if they're overdone or underdone, it can drastically affect tool life one way or the other. Okay, a little bit more detail. Unfortunately, the milling strategy controls a lot of those parameters. The only thing I can say about that is don't mess with that stuff. If you don't, just messing with milling strategies is not really recommended unless you have a really good grasp on what's going on. So top 5 things that affect tool life, and there are others, but I don't want to bore you guys to death. First is going to be your machine calibration and maintenance. So no matter what machine you're running, definitely calibrate it. Always keep up with the recommended maintenance schedule. It's easy to forget about that stuff because we're trying to get units out the door, and if the machine's dusty or something, who cares, right? But it's a huge investment for the lab, so definitely if you don't have a system in place, have some sort of standard operating procedure for calibration and maintenance. And if you're a little word on calibration, rule of thumb is the more units you make, the more you need to calibrate. And then also you want to be aware of the ambient temperature swing in your lab. A 10-degree Fahrenheit temperature swing can change the shape of your machine enough to throw a calibration off. So if you're not very precisely temperature controlled, then I'd recommend a daily, like morning calibration. A little bit more on milling strategies. So the milling strategy is what controls all those other parameters that I was talking about. And as an end user, you don't have a whole lot of control over it, but that's where it comes back down to who you partner with as far as support goes, because different companies look at this differently, and you want to make sure you're getting something that's validated with the tooling, with the machine, and the material that you're using. And then the last point on strategies is, don't neglect your updates, because they're constantly, putting out new strategies, things they're improving, milling times, efficiencies. It's important to keep up on that. So a lot of the CAM softwares have like an annual fee. It's usually pretty negligible, and in our opinion, it's certainly worth it. So here's another one that we kind of have a little bit of control over in the lab, and that's run out. So if you imagine a tool spinning, that tool it must spin in alignment with the spindle's axis. And any deviation from that alignment is called run out. And so if there's any vibration or wobble in the tool, what you get is a differentially loaded cutting dynamic. So one flute is doing more work than the other. And an imbalance in any system is bad. A really good example of that is this little GIF here. This is the Tacoma Narrows Bridge that was built, I think, in the late 40s, and they didn't take into account the wind load. And so what happened is that when it got windy, this thing started to resonate and it collapsed. So differential loading in any sort of mechanical system is bad, especially in tooling. And so here's what we get here. You get a non-uniform cutting load, like I said, and if you do have a severe amount of runout, like say that it's moving 50 microns, then your tool's actually going to cut a path that's 100 microns larger than the tool because it's wobbly. So then you can get dimensional inaccuracy and fit issues. This is a picture of a tool that was running out, and you can see that one flute is severely worn versus the other one, which is still pristine. So how do you control runout? The biggest thing in the lab is your collet. You know, manufacturers have different protocols for managing the collet, but they all do have protocols. Collet's a wear item. It's solely responsible for centering the tool along that spindle's axis, and it's only able to do a certain number of cycles, so they do wear out. This tool here, you can see there's some wear facets on this tapered portion of the tool, and this one is ready to go. So keep them clean, keep them inspected, and if you happen to have an issue where you're suddenly, you know, burning up tools, or you know, you've got fit issues or chipping issues that you just can't explain, the first thing to look at is the collet. I'm always fairly surprised when I run into you know, labs that don't maintain the collet. And then another thing that we can do about runout comes down to tooling quality again. So if you imagine real quick a burr, you have the cutting edge of the burr, and it needs to be machined perfectly concentric to the shank of the burr. And there's a lot of different manufacturing methods you can use to machine a tool. And some of the cheaper methods are not good at making that maintaining that concentricity. So cheaper burrs can actually have runout built into them, which you can't do anything about. So that's it's important to you know, select something that's ground precisely. Sierra tools are ground to a very, very, very tight tolerance. And then another thing as far as materials is you got to make sure you're considering you know, the material of cutting. You know, if you're cutting wax, you're pretty much never going to wear a tool, versus cutting you know, titanium, that's going to be really hard on tools. And so the thing as a lab that you need to be aware of is that the strategies need to be matched to the material and the tool. So you know, if you're I think some strategies have like soft and hard wax options or PMMA, and so just be aware of that when you're selecting your milling parameters. And next here, material evacuation. It's pretty common to see either underfed compressed air into a machine, like they're not, the regulators turned down too low, or a clogged vacuum system. But what happens with tooling is when it cuts, you inevitably make some debris, right? So that debris, you want to get out of that area as quick as possible, because otherwise the tool will actually recut that material, which you know, it's not doing any work for you at this point. It's just waste, and it creates another abrasion point in another area for you to get a heat buildup at the tool's tip. So definitely make sure your air is properly aimed. For those of you guys who have machines that are aimable, it should be aimed at the tool's tip. Run the highest reasonable air pressure. Certainly don't do anything outside of what your manufacturer recommends, and then keep your suction unit very clean. And you're going to have the best of that's possible on that. And I think this is the last point on tool life, and that's actually just handling the tool. Milling tools are precision instruments, and they're made out of tungsten carbide, which is a very, very hard material. But because it's an engineered device, it's designed to take a mechanical load in a certain direction. And the tungsten carbide, because it's machined to a sharp cutting edge, if it's traumatized in any way that it's not designed to be, it can chip and it can have defects. And if you introduce a defect into the cutting edge of your tool, one way or the other, you'll significantly cut down on the life of that tool. So we recommend keeping them clean, and if you're going to take it out of the machine and store it, put it back in its original packaging. And then one of the biggest things that we see is damage during installation of the tool. So when you're putting the tool in your machine, be very aware of where the tip of it is, and make sure you don't crash it into any little pieces of metal or the tool holder or whatever. In fact, you can see in this picture up here in the upper right, this is actually some brass that was on a tool that we inspected, and that's a telltale sign that we were impacting the tool holder on installation. So this next slide here, this is the same tool that was just dropped on the floor, essentially, and you can see the significant damage to the cutting edge. Now, instead of cutting with a nice pristine sharp edge, now I'm cutting with a blunt edge, and it doesn't really take much to imagine how that can affect the overall yield from the tool. A little bit about material and tool type. We're milling zirconia. You're going to have uncoated at the bottom of the spectrum as far as yield, and then there are some other coatings out there that are available. They're kind of like a mid-range yield coating. And then at the top we've got diamond, and a little bit on diamond. There's a lot of I guess misinformation out there about diamond. You can call a diamond light coating a diamond coating, but the word you're really looking for is CVD, which stands for chemical vapor deposition, and that's a process where we actually grow a real crystalline diamond. It's a nanocrystalline diamond directly on the tool, and that's done in some really highly space age precise equipment, and it's really the only way to get a real diamond coating on carbide. And then if you really want to get into the nuances, there's differences in the CVD coatings, but I'm sure if you want to know about that, we can talk about it offline. That's another half an hour conversation. And then grinding tools, if you're doing lithium to silicate, Emax, etc., that's going to be a plated grinding tool. And if you're milling metal, you'll see uncoated and coated tools. The biggest thing with milling metal is that you want to manage heat, and so our line of metal tools are very good at that. Or if you're and some of the same things come into account with metal tools. You want everything to be very accurate, especially when you're dealing with implant-based restorations. Alrighty here, so I'm gonna try not to run long here. So some of the issues with milling that come up, which I'm sure we've all experienced. We'll go through this kind of quick. So you've got generally you'll see chipping. That's probably the biggest thing. surface quality and fit, and then broken tools. So chipping, your main causes of chipping are probably most likely going to be, make sure your CAD settings are right, make sure your margin offset is correct, call and run out, calibration and condition of the machine. And then another little side point here, when you're milling and getting chipping, a lot of people think that it's the 1 millimeter tool, and yes, the 1 millimeter tool can cause chipping, but you also want to make sure you're looking at your 2 millimeter tool, because if you're, for instance, if you're milling with a worn 2 millimeter roughing tool and a brand new 1 millimeter tool, you can still chip, because that tool is actually traumatizing the material as it's cutting. So keep that in mind. And then obviously, if you're using a tool that's very, very worn, you're going to introduce chipping at that point. Surface quality. One of the biggest things that comes up that I see is lines or misalignment of top and bottom half. And 99% of the time, if you get a surface issue like that, it's a calibration or mechanical issue, especially those parting lines, like in that bridge above the in the top there. And what that is when the puck gets flipped, it's not aligned perfectly in either an X, Y, or X or Y direction, and so you get an offset. If you ever have a machine that's doing that, pay attention to the direction of the offset. Which axis it'll be aligned to an axis one way or the other. And if you can tell your support team that, that'll help them zero in on what to make an adjustment on. And then obviously, you've got overuse tool. That's going to be a through line. If you're running a worn tool, you can have surface quality issues. And then this is a little bit of a I don't know, humble brag, I guess. This PMMA bridge was milled with the exact mill, the exact same tools, and everything, but it was just strategy adjustments that we changed this surface quality, which was exciting to get go from something rough to something almost usable right off the machine. So parameters matter. And fits. My biggest tip on fits is think about where the fit issue is, and that's going to help you zero in on what's going on. So, for instance, I have a crown that's got tight contacts. Both of them are tight, and it fits loosely on the die. So, to me, when I visualize that, I think the entire crown is kind of too big. So I'm going to look at my scaling factor. I think maybe I might have mistyped the scaling factor into the machine. Or if you have a tight internal fit, but the external is good, that could be a CAD setting. That could be a worn tool or a low quality tool. So you want to pay attention to where the fit is. Don't just consider a fit issue. Break it down. And then finally, broken tools are always fun. The biggest thing, make sure they're in the right slots. If your machine's expecting a 2 millimeter tool and it picks up a 1 millimeter tool, it'll break it, guarantee it. Doesn't matter what tool it is. And then you want to make sure that the milling strategy is validated with a tool. So if, for instance, you use a tool that's not validated, the CAM software might not know the actual shape of the tool, and you can get impacts either with fixturing material or the actual part unit you're milling. And if a tool is impacted, from the side while it's milling, it'll certainly break. And then this is an easy one to do too. If you program your machine for a 14 millimeter puck and then you accidentally put an 18 in there, you'll break tools very quickly because it's taking too much material in the first pass. A couple little tips on that. Usually if you're breaking tools, it's indicative of a bigger problem. Tools really shouldn't be breaking if they're being subjected to the right environment. So Sierra Dental Tool is not a we're not the typical like tool supplier. If you go out into the industry and look at tooling, the vast majority of what you'll see is somebody who will sell you a tool and then turn and look the other way. Sierra Dental Tool looks at it as a team experience. Yes, we manufacture tools, but we also work with CAM softwares, machine manufacturers, material manufacturers, of course Zahn, very close with the support team and everybody over there. And what you get is you get products that are reflective of what the industry needs, and not just a product that was borrowed from industrial and sold as a dental product. And then secondly, we're very committed to education in general, and we actually have a education site that's called We Team Up. It's found at weteamup-dental.com, which I'll have the URLs and everything at the end, so you don't have to write it down. And basically, it's just an education resource. It's blogs, videos, digital education. And there's not a sales push. You're not going to find anywhere in there where I'm saying, hey, buy this or buy this. It's just one directional. We want to make sure that people are getting the best out of their situation from a CAD/CAM standpoint. And that's what it looks like. It's just a clean blog-based site, and you can read about a lot of the stuff that I'm rambling about in this presentation. I kind of threw this in at the last minute, but it drives the point that we're listening to the industry and we're constantly developing. So we're always testing. We have a network of beta test labs, and that ranges from the single man, single machine lab all the way up to the major production facility. And so we're constantly getting feedback on our tooling and development. And then we also do a lot of internal testing, and just recently run an internal test where we took our nano die product and milled a 1,000 units in zirconia. So I'll quickly run through what that test looked like real quick. What we did is designed nested a puck, 25 units, and ran it over and over and over again, and then broke out everything per tool, which is actually kind of fun because it's interesting to see how things progress. This is the test program, and it's broken down by tool. So this is kind of an interesting thing to think about tool too when you're thinking about toolware. A typical program is going to be mostly 1 millimeter tool paths. So you can see this one runs the 1 millimeter for 4 hours, where the 2 millimeter only runs for 1.6 hours. And it generally runs about in that ratio. It's like a 1 to 2 ratio. And then the 0.6, as you can imagine, doesn't do very much. It's only doing your detail run. And so you'll see that the wear on a tool actually develops along this ratio, which is kind of interesting to see. So here we are at 50 units. There's nothing, no wear at all. And 250 units, looking good still. 500 units, we're starting to see a little bit of wear facet on the 1 millimeter, tiny wear facet, but nothing to be worried about, still getting very good results. 750 units, it's essentially the same situation. And then around 1,000 units, I'm starting to see some wear on my 1 millimeter. And it's still got some life in it, but the test was just, to illustrate 1,000 unit run. And so the point being here is that we back up what we say. We advertise that the nano die does 700 units, but that's somewhat of a detune so that we don't set a really high expectation. But the point being is that a quality tool really does go the distance. Let's see here. I'm about 40 minutes in. I'm going to bust through this real quick here. So quick overview on products. The majority of what I've been talking about has been nano die. We make tools for all cutting, all mills that are on the market, essentially. Then our razor sharp. These are our uncoated tools. They're better than other uncoated tools because they have our geometry that's developed for dental, and they also have a surface treatment feature to the cutting edge that makes it much sharper. And so since the tool starts off sharper, it wears longer. So in zirconia, you'll get 150 units instead of 50, comparatively to another carbide. And then in soft materials like wax PMMA, much better surface finishes and fits. This is certainly proven in the industry. People are very happy with these tools. And then if you're cutting metal, we make a great line of metal tools. They're called Tyco. Proprietary coating, our geometries that are optimized for titanium. We also have a line of grinding tools. So if you're doing Emax blocks or any other sort of glass ceramic milling, we've got you covered there. So I've got a couple of new things to share with you guys. First off, Tornado. This is a new tool for the roll-in system, unfortunately roll-in system only. And what it is it's a new feature along the shank of the tool that addresses the issue of material evacuation. So essentially what it does is, as the tool's running, it creates a low pressure zone around the tool that helps move material away from the cutting area. And what you get is a longer life and better results overall. So if you're not familiar with Tornado, it's certainly something to look at. And then I've got a quick video of it running. So you can see, if you look closely, you can kind of see the vortex form around the tool. It's pretty neat to watch. And this is being milled to demonstrate without any air or suction. So again, it's nano die on the Roland. Your Zahn salespeople know all about them. They can help you out if you want to try them. And then the second fun thing, which is newer than Tornado, is our razor sharp rapid removal tool. And this is developed for the Roland platform, and it's an answer to the need for reduced process times in plastics. So if you're starting to do digital dentures or any of the other plastic restorations, you'll find that it takes a very long time to mill them. The majority of the time that's used up in the current state of things is the roughing. So it takes a long time to actually bulk remove that material. And so we looked at that and designed a special tool that's got geometries that are going to help reduce that process time by increasing the amount of material the tool can rough. So we can actually remove 6 to 7 times the volume of material than the standard geometry tool can. And this is a little video of the tool roughing 3 millimeters of wax in one pass, which is pretty cool. This is actually a video of the tool roughing the entire disc away, which took 8 minutes. So it went from a 14 millimeter disc to nothing in 8 minutes, which is pretty sweet, I think. So I'm not going to get too deep into that, but into the features. But essentially, it's a hogging tool. It's meant to just remove material fast and get to the point in the material into the program where we're doing finishing. They're working on the mailbox update, which I think we expect to hit very quickly, maybe in the next week or so. And so if you're current on your mailbox license, you can order the tool and get an update, and then you're off to the races. So it's as simple as that. And the way it's set up in Mailbox right now is it defaults to the original tooling, but you can select to use this tool if you've got it. So again, we're looking at workflow as a system, and the importance of tooling in that system. Make sure that you consider what you're getting when you're looking at tooling. With that, I'll jump in, see if we've got any questions here. Okay, so I've got, what is the general margin thickness you recommend running from your experience? So people like to get aggressive because we don't like to finish those margins down in the lab. 200 microns is the minimum. If you go to 250 microns, if you can deal with that in your production, you'll have less chipping. I know there are labs out there that go down to 50 microns, but it's a sliding scale. So the thinner your margin, the more you're going to chip no matter what. Let's see what else we've got here. Okay, so have you tried, this is Joel, have you tried testing the razor sharp with bite splints and PMMA? Absolutely. In fact, I have one here in front of me. This is a bite splint that was machined with on a Roland machine with the new tool in an hour and a half. And the webcam doesn't do it justice, but it's got a very, very nice surface finish. So yes, we definitely do test on bite splints. Okay, which tool was available to get 1,000 units, or does it work in Motion 2? Yeah, so we do have tools for Motion 2, and it's the same thing. It's the nano die is our nano die coating on our tools for that machine. You can call your Zahn rep, they'll have everything, and they'll be able to get that to you. Let's see, average lifespan of the 1 millimeter coated tool. Let's see, so to answer the lifespan thing, it's a function of material, mill, and the environment that the tool's in, just like the tire analogy I made before. So if everything is ideal, 700 to 1,000 units is very achievable. If there's something else going on, it can be less than that. Or if you're milling like a soft zirconia, we have labs that that'll go above 2,000 units. So we base all of our business cases off of 700 units because that's we feel like that's a conservative number for most applications. When will the Rapid Razor be available for Veal and Select? That's Darren. So not at this time, but we're going to be looking at that platform next after we're done here with the Roland system. Let's see here. The tools you discussed only for Roland milling machine. Yes. Right now, the Tornado and the Rapid Removal are for Roland applications. And Darren's question there, we're looking at rolling it out into other systems also. How do we get the milling strategies for these burrs? That's Dean. So it depends on who is your reseller. If you're a Zahn or Cap customer, you already have them. For the new tool, that's just an update. So you need to update your Millbox version, and with that update will come the new strategies and settings for that. Let's see. Just have one that says on zirconia. I'm not sure what that is. What other cam options are for Veal and Select, and which is best in your opinion? So Vealand is closed. I'm not going to endorse a specific cam supplier, but it's fairly easy to if you want to make the investment in an open cam. The two that come to mind are Sum3D and Hyperdent. They're both very capable. I would recommend contacting those companies and taking each one for a test drive and deciding which one you like better before you make that decision. Let's see here. I think I've gotten to most of them. Will an update to the older version of Sum3D have the option of getting milling strategies, or do we need Millbox? So Sum3D is the guts of Millbox, like you said, Dean. And the answer to your question, if you're used to using Sum3D, you don't absolutely need the Millbox, but you need your licensing to be up to date. And with the licensing, you're able to run the new strategy. So you can look and see where your licensing is on Sum3D. If you just go to, I think it's Help and About, it'll tell you where your, what the date of your dongle is. And your Sum3D reseller can help you out with that. It's not an issue. Let's see. I think that's it. I might have skipped over one. Let's see. I think I answered most of them. Is there anybody else who has any questions, or are we doing good? Oh, here come a few more. Let's see. What's the air setting at? Joel. So we set, the test, the video from earlier, the air was set at 0, it's off, in order to take that video. Now, I recommend running the stock air setting, which I believe on the Roland, don't quote me, I think it's like 0.1 bar. I just go by what the manufacturer says on that. My unofficial opinion is that higher the better, but the manufacturers set their settings because if you run a air pressure that's too high, what you can end up with is you can be pushing the zirconia powder into the mechanics of the machine and cause it to wear prematurely. And so there's a balance there. For a tool, I want 2000 psi on that thing. Just get it clean. But that doesn't really work in the machine. So there's other things that come into account, and that's why I say just look at your manual and run it right there. See, what's the next question? Is there going to be a video of this webinar? Yes, Amanda will be putting it up on YouTube. I'm not sure what the time frame is on that. Maybe can you speak to that, Amanda? Is that a couple days or?
Yes, usually we try to edit and send it out as soon as possible, but please wait a few days just for processing.
Okay, great. Yeah, so yeah, absolutely. This is going to be available on the Zahn channel. This is a great question, Dean. How do the nano burrs differ from Zahn's ultra diamond burrs? As everyone's very well aware, Zahn bought CAP, and prior to that acquisition, Sierra Dental Tool manufactured the tools for CAP. And so post acquisition, the ultra diamond tools and the Zahn tools are actually the same exact tool. They just had different labels on them. And we're actually rolling out an effort currently that is combining the labeling on those tools. So coming up, I think in May, there will not be any more CAP branded, ultra diamond tools. They're just going to be the Zahn Sierra nano die tool. So that's to answer the question. Thanks everybody for joining. And again, Sierra Dental Tool is there to help you. We're not just about putting a tool in the market. We want to support it as as a system. And Joel is asking me if I still go by CAD Cam Greg. That's funny. You can call me CAD Cam Greg if you want, Joel. He's referencing to I used to make these wax pucks before I worked with Sierra, and I called myself CAD Cam Greg. Kind of funny inside joke. Thanks, Joel.